Small workshops utilize traditional sand casting to ensure Pakistani businesses have access to cost-effective giant gears. Though this method is slower, combined with simple mechanical equipment, it can produce precision-structured giant gears. Given the massive size of the gears, traditional sandboxes are insufficient. Therefore, craftsmen dig a sizable circular pit in the ground to serve as a casting sandbox. After digging the pit, they lay a layer of highly cohesive and excellent plasticity sand at the bottom, ideal for making large workpiece molds. Experienced craftsmen use a square tube and level to create a flat base. Once the sand is laid, craftsmen poke many small holes at the bottom and inject carbon dioxide to harden the sand quickly, forming a solid base for casting. After the base hardens, a sun-shaped gear mold is placed at the pit center, and the top layer gear mold is covered, forming the initial gear model. They then start making the teeth, which is more straightforward. Fill the mold with sand, compact it, and inject carbon dioxide to harden the sand, forming precise tooth molds. These teeth are precisely placed on a positioning device, where the tooth slots match the tooth models, ensuring accurate placement. Casting the rectangular gear requires 16 tooth models. Once the tooth molds are in place, craftsmen refill the gaps with sand to seal the mold completely. They backfill the pit with surrounding sand, supporting and fixing the gear model. To enhance stability, they compact the backfilled sand and lay another layer of molding sand, forming a square platform. For the upper mold, supported by iron ore and reinforced with steel bars to prevent cracking under high-temperature molten iron, craftsmen add vents and pour holes using red bricks to remove gases during pouring, preventing mold breakage. They compact the sand inside the iron ore, ensuring the upper mold's solidity. With the upper mold completed, craftsmen use a crane to remove the model from the pit, extracting the wooden parts of the gear mold and leaving the gear's basic shape. They then position a cylindrical sand mold at the gear's center, marking the axle hole. The upper mold is reassembled, and all gaps are filled with sand to prevent iron spillage, adding heavy weights to avoid displacement during pouring. With preparations complete, the large casting mold is ready for molten iron. Meanwhile, at the workshop's other end, craftsmen select metal raw materials for melting, mainly sourced from scrap machinery, vehicles, and other metal waste. They feed these materials into a large induction furnace for melting. Quick reactions are crucial during feeding to avoid dangers. In about 2 hours, the iron melts completely. Using a hydraulic system, they lift the furnace and pour iron with impurities for preliminary cleaning. After removing impurities, the clean iron is transferred to a large ladle holding at least 3 tons, highlighting the gear's enormous scale. The ladle is then moved to the casting site, and hot iron flows into the mold through a chute, creating a fiery spectacle. Craftsmen monitor the flow, ensuring the mold is filled even. After the mold is filled, the casting cools naturally for 24 hours, which is critical for ensuring the gear's structural integrity. After cooling, they lift the formed gear from the sandbox using a crane. The tightly adhered sand, especially in the deep slots, poses a cleaning challenge. High-powered jackhammers break the hardened sand for removal, revealing the clean metal surface. The gear takes shape at this stage, but requires precise cutting to remove casting residues and achieve the final shape. Although the gear is cast, it's a rough blank needing machining. The gear is moved to the workshop using a crane and secured in a lathe. Initial rough machining removes excess material, forming the general outline. Experienced craftsmen control the lathe for efficient shaping. After rough machining, it enters the delicate machining stage, where precision is crucial. Tool contacts are minimal, speed slower, and steadier, ensuring detailed accuracy for performance requirements. Post-surface turning, the gear undergoes shaping. Craftsmen mark the gear's tooth surface, fit the gear model, and trace cutting lines. The gear is carefully mounted on a shaper, ensuring correct positioning to avoid errors from vibrations. The shaper follows preset paths to cut each tooth, ensuring uniformity and symmetry. Craftsmen monitor tool work closely to maintain continuity. After about 48 hours of precise machining, the giant gear is finally completed, showcasing Pakistani artisans' high skill and craftsmanship. Despite limited resources, they can produce large mechanical parts that meet strict industrial standards, which is truly impressive. Their craftsmanship and dedication reflect their expertise and innovation in mechanical manufacturing. What do you think about the technology and craftsmanship of Pakistani artisans making giant gears? If the highest score is 10, what score would you give them?